In this video, we want to look at the Slutsky equation, which describes the relationship between the ordinary or Marshallian and compensated or Hicksian demands. You can see this in the diagram here, where we have the compensated demand function, which is a function of price and utility, and the ordinary demand function, which is a function of price and budget M, intersect at point A. And we're going to take that fact of intersection at point A to derive the Slutsky equation. Now, in the past, the Slutsky equation was derived in a way that did not take advantage of that and relied on second-order conditions and all other kinds of things. And I recall a professor of mine taking 2 days to derive the equation. However, we're going to do it by looking at point A, where the compensated demand function and the ordinary demand function are equal, and what we're going to use is the fact that we have this expenditure function which is equal to M. So we write this as the compensated demand is equal to the ordinary demand, where ordinary demand is a function of price, and the expenditure function, which is in turn a function of price and utility. So we're going to differentiate both sides, the compensated and the ordinary demand functions, for good J. And we're going to differentiate with respect to Pi. We could do it also with respect to Pj, and we'll get that solution to you in a diagram at the bottom. So we first take the partial of the compensated demand for J with respect to Pi, and then that's equal to the partial of the ordinary demand for J with respect to P. So of the partial of the ordinary demand for J with respect to M multiplied by the partial of the expenditure function with respect to Pi. Note that price is, or P is, a vector of prices. We know that the partial derivative of the expenditure function with respect to Pi gives you the compensated demand function for I, but at point A, the compensated and ordinary demand functions are identical, so therefore we can write this equation as the partial of the compensated demand for J with respect to Pi is equal to the partial of the ordinary demand for J with respect to Pi plus Qi, the ordinary demand function, times the partial of the ordinary demand for J with respect to M. So rearranging this, we get the partial of the ordinary demand for J with respect to Pi is simply equal to the partial of the compensated demand for J with respect to Pi minus the ordinary demand I multiplied by the partial of the ordinary demand for J with respect to M. And you'll notice that the left-hand side is the total effect, the first term is the substitution effect, and the third term is your income effect. So the Slutsky equation effectively decomposes the changes in these, decomposes a change in demand Qj due to a change in price into these separate effects. And we're going to look at what happens when you get delta Qj. So in other words, you get an actual change in the demand for J when you change the price in Pi of another good by some amount delta Pi. And we can separate those effects. So we can look at the change in demand for J, which is decomposed, or is equal to, rather, the partial of the demand for J with respect to Pi multiplied by the delta Pi, the change in Pi. And that's equal to the substitution effect and the income effect. So the substitution effect is the compensated demand for J with derivative of the compensated demand for J with respect to Pi multiplied by that change in Pi minus the partial of the ordinary demand for J with respect to the budget M multiplied by Qi times Pi, where Qi is just your ordinary demand at that point. The matrix of substitution effects turns out to be symmetric, so that the partial of the compensated demand for J with respect to Pi is equal to the partial of the compensated demand for I with respect to Pj. We can reword that as follows, as the partial of the ordinary demand for J with respect to Pi plus the ordinary demand for I multiplied by the partial of the ordinary demand for J with respect to budget is equal to the partial of the ordinary demand for I with respect to Pj plus Qj multiplied by the partial of Qi with respect to M. So in other words, we've just taken these terms and we've substituted the right-hand side of the matrix up above. So we can look at this from a diagrammatical point of view. So we begin with a budget line here, and we start at point A, and now we're going to reduce the price of Q1, keeping Q2 constant. That shifts the budget line in this way. When you reduce the price, we then take a line parallel to the new budget line, and we shift it so that it's tangent to the old budget, the old utility function at point B. Then A to B is your substitution effect, and then B to the higher level of indifference, the higher level of utility moves you to C, so B to C is your income effect. Thank you for watching this video. There are many more videos in this 2 to 3 course series. A list of videos, the order in which they should be taken, and links to them are found under Mathematical Economics at the website indicated below.